So chemical bond. Okay, we will be discussing a bit about the structure of a molecule. Okay, I'm just marking it with a star that this is not in your syllabus. So don't worry too much about it if it looks too weird. Now, suppose you want to decide a structure of a molecule. Suppose there is one center atom B along with two bonds around it. It is a linear molecule. Okay, because the bond tries to be at maximum distance from each other. Now, it is not just the bond, it is about the electron pairs. So if the electrons, see, each bond consists of an electron pair. So there are two electrons pair, so they will try to be at maximum distance from each other. And the best possibility is to have a straight line. Okay, so I'm just using the term if you have two bond pairs of electron. I'm calling these electrons as electron pair. So if you have two electron pairs around the central metal or central element, they try to be at maximum distance from each other. Okay. If you have three around the central metal, they will again try to be at maximum distance from each other. And it will look somewhat like this. This is called as triangular planar. It's a triangle in one plane. So it's triangular planar. If you have four of them, then they will try to arrange themselves at maximum distance from each other. And it will be a 3D structure, not a 2D structure anymore. It will be a tetrahedral. Okay. So it's a tetrahedral where all the bonds are at maximum distance from each other. It's more like a triangular pyramid. It's like a triple covalent bond. I did not get your point, Natraj. Can you just tell me what you're trying to ask?
So three electrons, like three kinds of electrons sharing at the same time.
Huh?
Triple covalent bond.
No, it's not a triple covalent bond. Triple covalent bond is like this. Three shared with the
Yeah, three dash. Yeah.
This is three different bonds. Okay.
Okay, sir.
So if you have four bonds around a central element, like if suppose there is one element combined with four different elements, then the structure is like a trigonal pyramidal. This is a 3D structure where like you have a pyramid with three of them at the corners, like all the A's at the corner of the pyramid and B's in the center of the pyramid. Okay. So B's in the center and A's are on the corner of the pyramid. I think you're understanding the 3D nature of this. Similarly, if you have more than three, that's though not required in our syllabus. If you have four of them, then three of them will be in one plane, one will be above and one will be below. So three in one plane, one above and one below. You will hardly see such molecules, so we are erasing them for now. So I'm just trying to explain you for 1, 2, 3 and 4 elements, electron pairs are about a central matter. Fine. Let me take example of water molecule. if you are thinking about water molecule, this oxygen has 1, 2, 3, 4, 5, and 6 electrons. So 4 are personal electrons and 2 electrons are being shared. Okay. So this oxygen has total of, so this understand very carefully. This is where things might become little tricky. So this oxygen has total of 1 electron pair, 2 electron pair, this is 1 bond pair, and this is 1 bond pair. So this oxygen has total of 4 electron pairs around it. All right. So 4 means the structure will be tetrahedral. Okay. So it's a 3D structure. Let me just take a tetrahedral. Okay, so as you can see, this is how the tetrahedral structure looks like. Some of you are already discussing something else. Lost interest already. One second. Okay, this looks better. Okay. So I'm saying this oxygen has 2 bond pairs, 2 bonds around it, and 2 individual electron pairs. So these 2 electrons are considered as 1 pair of electron, and this one is considered as 1 pair of electron. And these are considered as bond pairs of electron. So these bond pairs are in one direction. So you have hydrogen like this and other hydrogen like this. And these electron pairs are in one direction. Are you getting the point? So 2 of the electron pairs are on 2 sides of this tetrahedral, and the 2 bond pairs are like this. The 2 hydrogen are like this. Is that fine? Therefore, the structure of water is not straight. As you can see, it is bent. As far as these electrons pair are concerned, they are there, but they are invisible. They are just there, but you can't see them. You can only see this oxygen in between, and you can see these hydrogens around it. Does that make better sense? Okay. So whenever you are looking at the structure of any molecule, you need to see even the electron pairs along with it. Suppose we have another structure, let's say ammonia. Nitrogen has 1, 2, 3, 4, 5 electrons. Out of this, 3 is sharing electron. 3 electrons are shared with hydrogen. So there are 1, 2, 3 electron pair and 1 lone pair of electron. So totally 4 you have. So the structure will again be like a tetrahedral. So even in ammonia, the structure will be like a tetrahedral like this, where this is the central nitrogen. You have one hydrogen, other hydrogen, the third hydrogen, and above you have this lone pair of electron, but this is not visible. Okay, so this is how the structure of ammonia will look like. So whenever you're deciding the structure of a molecule, along with these bonds, you need to even check if there's electrons left around it. If there are electrons left around it, they will also occupy some space, but they will just remain invisible. I hope this point is clear to everyone. I will not elaborate too much about this because you'll be studying this in higher classes, but I hope this water example makes some sense. Okay. So at least you understood why this water has a bent structure and not a straight structure. Because this oxygen has two extra electrons and they are also occupying some space, which is repelling these bond pairs. So they also have some space. So it's totally tetrahedral, but these are invisible. Okay. So that is all I wanted to explain you here. Let's move further to the next thing. Okay, we have studied ionic bond and covalent bond. The next thing we want to study is coordinate bond. Okay, this is something new for you. You have not studied this in previous classes until you have figured out this from somewhere else. Now there is a possibility. Suppose there is a nitrogen forming bond with hydrogen. So this is ammonia. Okay. Nitrogen has a lone pair of electron. Pranav Reddy says dative bond is called as coordinate bond. Pranav Reddy, will you help me understand what is coordinate bond? I think you know about coordinate bond. Help your friends understand. Can you speak up now?
I just guessed it, sir.
You just guessed. Dative bond is, you guessed it. That's not that easy to guess. Ishan Arya, will you help me understand? You got highest in chemistry.
Sir, Pranav already knows, sir. He was teaching.
He knows he was teaching you.
No, sir. He lie.
He'll teach in school, sir, for everyone.
He is teaching everyone and...
Shit ke way.
Okay.
So,
So,
he's topper,
No, sir.
sir.
who is the topper here?
Reddy, sir.
Narsima, sir.
Pranav Reddy, sir. Ask anyone.
Pranav Reddy, sir.
Eh.
Oh, Pranav Reddy is topper. Okay.
No,
But I
sir.
don't like toppers, sir, because I was never a topper in my school. I like only student who enjoy subjects, not who get good marks.
Yes, sir. Same, sir.
Average student, sir.
Huh?
Kala like
Average,
Jay.
average.
Shit ke stopper.
I like average students and more than that, weak students.
I am weak student, sir.
Okay.
Kala
Then
students like Jayesh.
okay, no problem. See, I like all the students. It's not like I personally dislike anyone. But let us understand if someone of you know like what is a dative bond. But those who don't know, let me explain you very properly. Now see, you know covalent bond, there is one element A which has an electron and there is another element B which has an electron and they start sharing electron, right? This is called as covalent bond. As if A is one friend and B is another friend. A has a bat, B has a ball, and they go out to play together. So they're sharing the bat and ball, right? That is covalent bond. Correct. Ionic bond is A had the bat, B had the ball. A says, you take my bat and ball and go and play. I don't want my bat. So he's donating his bat to B, right? So he has donated. This is ionic. Correct? I think these two things are clear. Coordinate bond is like this. When A has a bat, and a ball, he tells B, come, let's play together. Okay, so let's play together. So A is not donating anything. He's saying you can come and share both my bat and ball. Yeah, so they are just sharing. They're not donating. He's not giving it to him. He says, see, I have both bat and ball. You can come and share with me. Okay. So if I try to draw this more in chemistry terms, in ionic bond, A has an electron. A's electron is with a dot, like covalent bond. B has a cross, and they start sharing this electron together. This is covalent. In ionic, A donates the electron to B, says you take my electron and go. So A gets a positive charge, B gets a negative charge. This is ionic. In coordinate, A has 2 electrons. A doesn't get a profit. He's a good guy here. So B has a negative charge. Like B has nothing. Okay. And A says, I will be sharing both my electrons with you. So we show coordinate bonds with an arrow like this. So A is still sharing, and it is sharing both the electron. Okay. So A is not selfish. He is like really kind and giving. He says, fine, no problem. You don't have anything. I'll share both electrons. So here A gets nothing. Okay. And because he's sharing 2 electrons, B gets a profit of 2. In ionic, A loses 1 and B gets a profit of 1. In covalent, A gets a profit of 1 and B gets a profit of 1. I hope this point is clear to everyone. All right. Good. Now, see this poor hydrogen. This is just a proton. You know, hydrogen is made up of 1 proton and 1 electron. This doesn't even have an electron. Suppose this hydrogen donates 1 electron to someone else. This will become H+. That means it just has a proton. So this is nothing but just a proton. H+ is just 1 proton. Correct? So this proton was freely moving around in a solution. See, H+ will never be alone. So suppose you take HCl, okay, and dissolve it in water. So you have H, or dissolve it in ammonia solution. This is ammonia. Okay, try to understand the situation of this H+. Okay, see what I'm saying may sound a little weird here, but just interest, like I have made these stories to create little interest in my subject. This is not given anywhere in your textbook. So this is mostly for the student who don't like chemistry. For those who like, you can understand it without such examples. Okay, I never liked chemistry, so I made such examples for myself. So you have this hydrogen plus, you know, it's just a proton. It's a small element. Okay. And this is sticking to Cl minus. So it is with Cl minus, and you know, chlorine is a big molecule or an element. Atomic number 17 and this is atomic number 1. So you can figure out the difference. Okay. So they were giving and taking electron to each other. But here they realize the hydrogen feels that I'm a smaller partner and I am getting less value here. Like it just doesn't feel comfortable being so small. So he just approaches this ammonia and tells, okay. And see, along with this hydrogen approaches this ammonia and tells that, see, I'm a small partner with this chlorine, and plus this chlorine has taken away my electron. So I don't have any electron. Okay, I'm simply sticking to this big chlorine. Can you stick with me and make me look bigger? Okay. So this nitrogen says how? It says the hydrogen tells to this nitrogen, see, you have a lone pair of electron. You have two electrons. My orbitals are empty. I don't have any electron. You can share those two electrons with me so that I can get two electrons. Plus, I'm already giving that one electron to chlorine. So I still have a positive charge. We will together stick with this chlorine. Are you getting my point? So this nitrogen says, okay, fine, but then there's no option. Nitrogen says, I cannot donate my electron. Okay, because if I donate my electron, I'll be deficient of electron. I already have 8. This nitrogen had 5, and after sharing 3 with hydrogen, now it has 8. So if it donates electron to hydrogen, it will get deficient of 8. So this says, better than that, I will form a coordinate bond with you. Yeah. So this says, I'll form a coordinate bond with you, with this hydrogen. But effectively, they had already given this electron to this chlorine. So this ammonia, this whole thing NH4 has an effective positive charge, and this chlorine has a negative charge. How this helped this hydrogen? Now it became big. Instead of a small H plus cation, it became a big NH4 cation. Are you getting the point? Anyone has a doubt here? Okay. So this was the story of formation of ammonium ion. So ammonia, which has a lone pair of electron, combines with this H plus and form ammonium, NH4 plus. So there are 3 of them are covalent bonded and one is coordinate bonded with this H plus. Overall, they have a positive charge and that can stick with any anion. Ammonium will never stay in nature alone. So this can't stay alone. It has a positive charge. So it needs a negative charge species to balance it. So you will be seeing ammonium chloride or a ammonium sulfate, something. So I think you understood how ammonium, which is NH4 plus, is formed from ammonia. Correct? This is ammonia. And this is ammonium. Ammonium is a cation, while ammonia is a molecule. Anyone has a doubt about it can ask me here. Don't hesitate. Okay.
Okay. Sir, so NH4 is a cation.
Is a cation. This one ammonia molecule forms a coordinate bond with this hydrogen, forming ammonium from this H plus. Okay, so this and this forms a coordinate bond with this hydrogen to form ammonium.
Okay, sir.
There is another instance of coordinate. Let's say you have water molecule and NH3 is not an anion. NH3 is a molecule. It doesn't have a charge.
Sir, what is the difference between it, sir? Cation and anion.
Cations have positive charge, anions have negative charge. And what doesn't have charge is a molecule. Okay. So all this Ca2 plus is a cation. Mg2 plus is a cation. The negative ones like SO4 2 minus is an anion. Does that make sense? Okay. So I hope this part is clear to all of you. Now, this water, when it combines with one H plus, it does the same thing. Okay. where this H plus combines with this oxygen. It says you give me one lone pair, you share a lone pair with me. This oxygen starts sharing this lone pair with this hydrogen, and overall they have a positive charge. This is called as hydronium ion. This is like a hydrogen cation. And this is water molecule. So the hydrogen cation combines with a water molecule to form hydronium ion. And even in this case, this poor hydrogen who had already lost his electron to some anion, right, is looking for someone who can share two electrons and help him a bit. So this oxygen is helping him with two electrons. Correct. But because it has already given that one electron to someone, it has a positive charge. So it cannot leave that one also whom he has given electron. So that will still stick to this whole thing. So if suppose that negative one is chlorine, this whole will combine with this, forming a hydronium chloride. Correct. So at least in your syllabus, like for now, we will be seeing that anion part in acid, bases and salts. First, you understand this cation is sticking with this water molecule through a coordinate bond to form hydronium ion. Correct. One question is asked in exam. What if the another hydrogen combines with a lone pair of oxygen? Which other hydrogen, Sweta? Acha, you're saying with this other lone pair, is it what you mean?
Yeah.
Oh, that is actually might be theoretically possible, but practically it is not possible. Okay. Practically we have no evidence, because see, chemistry is all about possibilities, and there are infinite possibilities of things which might happen. But practically we hardly have an experience of any such molecule where this oxygen even donates the other lone pair. Okay, so chemistry is all about infinite possibilities, and I will show you one possibilities here just after this example. So let me talk about one compound. Name a compound okay, which has all ionic, covalent and coordinate bond. So can anyone name a compound which has all ionic, covalent and coordinate bond? The solution for this, like I want someone to tell me the answer if possible, if you know. Not water. Water only has a covalent bond. Like oxygen has two covalent bond with this hydrogen. Okay. So the correct answer here will be ammonium chloride. Ammonium chloride, if I draw the full structure, it will be like this. Ammonia and this hydrogen. The whole thing has a positive charge, and then you have a negative charge. So if you observe carefully, these red ones are covalent bonds. Okay, this blue one here, or if I make it green here, so this one is a coordinate bond. Correct? And the whole ammonium and chlorine has a ionic bond. Yeah, you can even take example of ammonium hydroxide, ammonium nitrate, any ammonium salt is fine here. Is that fine? This question has been asked in both plenty of time. I hope you are able to understand what I'm trying to say. So if they ask you this question, name a compound which has all ionic, covalent and coordinate bond, the correct answer will be any salts of ammonium. Ammonium chloride, ammonium hydroxide, or anything like that. Is that right? Okay. See, I think you are understanding how bonding takes place, and your curiosity will drive you in just imagining new compounds. But do you know, like, this world is already filled with infinite number of compounds which we already know. So it is a better approach to learn the structure of molecules which already exist rather than trying to create your own structure. And if you try to question why it happens, why it doesn't happen, it really looks very complicated. So this is all you have. Ammonium oxide doesn't exist, Pranav. If it had existed, then I would have said it is correct. Fine. So it doesn't exist in nature. No one has seen an ammonium oxide. So that is what I'm trying to say. You might be wondering, your curiosity will drive you towards imagining that maybe this is the example, this is the example. But try to pick up from the example which already exists around you in nature and try to understand their structure, because there are already millions and billions of compounds which exist. Let me try to draw one structure of a covalent bond, covalently bonded molecule. It's a big molecule. It looks somewhat like this. Okay, how many bonds a carbon can form? Can anyone tell me how many bonds a carbon forms? Carbon forms 6 bonds, Natras. No, it doesn't form 6 bonds. Dax is saying 12 bonds. Don't look at this structure. Okay, leave this structure.
Four.
Just one carbon can maximum form how many bonds? How many bonds?
4, sir.
It forms 4 bonds. And what about oxygen? Okay, oxygen forms how many bonds? It can form 2, right? Because it has 6, so it needs 2. Carbon has forms 4, so it needs 4 more, right? What about hydrogen? Hydrogen has 1, so how many bonds it can form?
2.
No, hydrogen. Just 1. Right? Hydrogen will just share 1 electron with someone else. Oxygen, because it has 1 and it needs 1 more. I hope this is clear to everyone. Correct. I'm just talking about sharing here. Leave the coordinate bond earlier. Like, I'm just trying to show you the applications of bonding, and it will, just for the sake of fun, it's not in your syllabus. Okay. So I am drawing a big structure here, and I will make sure that every carbon in this structure has 4 bonds. If I have not drawn 4 bonds, you can object. Okay, let me go one by one. So this carbon has a bond with oxygen. Okay. Which again has a bond with hydrogen. And then this has a bond with hydrogen. This carbon has a bond with hydrogen, and then a bond with oxygen, and then a bond with another hydrogen. This carbon has a bond with oxygen. All covalent bond, no other bonds, Natras. They're all covalent bonds. Each of them is sharing 4 electron. This is hydrogen, this is oxygen, and this is a hydrogen. Here you have a hydrogen, you have a carbon, which has another 2 hydrogen. Then you have an oxygen, and then you have a hydrogen. Look at this structure and tell me if I have gone anywhere wrong and I have not satisfied these 3 conditions. Look at every single carbon. Look, like this one has 1, 2, 3, 4. This one has 1, 2, 3, 4. This one has 1, 2, 3, 4. This carbon also has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. This carbon has 1, 2, 3, 4. So I am satisfying carbon. All carbons are correct. Look at the oxygen. This oxygen has 1 and 2. This oxygen has 1 and 2. This oxygen here has 1 and 2. This oxygen here has 1 and 2. Even this one has 2. This one has 2. And look at all the hydrogen. Are they all making 1, 1 bond? So am I right? Have I satisfied this condition correctly for all of them? Or I have gone somewhere wrong? Does anyone think I have gone wrong? No, I have not gone wrong. So it's all correct, right? Good. Now you might be wondering, sir, why I am doing this. Ishan Arya, have you seen this thing before? Ishan Arya, I would like to speak up. You to speak up. Have you seen this thing before? You got highest in chemistry, so it will help me a bit with my discussion.
No, sir.
You have never seen this thing before?
No, sir.
You have ever heard about this thing? No. I can promise you have heard about this. Okay, let me count the carbon. How many carbons are there? 1, 2, 3, 4, 5, 6. Is carbon 6?
I guess it's glucose.
6, H12. And hydrogen is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And oxygen is 1, 2, 3, 4, 5, 6.
O6.
Has anyone heard about this thing before?
Yes, sir.
Yes, sir. Glucose.
Glucose, sir. Yes, sir. Glucose.
This
Glucose,
is.
sir. Turn.
I hope you understood
Glucose.
what I'm trying to tell you. Correct. So even very big molecules like this ensure that this chemical bonding condition is satisfied. Okay. So this is the structure of glucose. Was that clear to everyone? So I hope you're familiar with this thing. This is not something new. But we only learn it like this, C6H12O6. I'm just trying to help you understand the structure of glucose. Fine? Okay. See, this is, Natras says in bio he has seen the structure. Okay, no problem. But in bio they won't have explained you the structure. I'm just trying to explain you the structure here. Good that you have already seen it before. Okay, so it's good that some of you already had seen the structure, but this is how this glucose looks like. But even glucose is made from, after satisfying the basic chemical bonding structures, conditions, correct? Okay, tell me what is a valency of carbonate? CO3 to minus. I think this is how the carbonate looks like. Okay.
Yeah.
Jayas, why is it this -2 carbonate valency is -2? Why do we say it's -2?
Don't know, sir.
Okay, you know chlorine. What is valency of chlorine?
1 minus.
Why is chlorine valence -1?
It will receive 1 electron.
That you know. So this will receive, or this has already received?
It received.
It has already received. That is why I know minus sign. Chlorine sign is normal. Okay, well, once it receives, it has already received the electron. Okay, after taking the electron, it becomes minus. So it has taken 1 electron, right? And the CO3 has taken how many electrons, Jess?
2 electrons.
Okay. You know why this chlorine took 1 electron?
Yes, sir.
Chlorine electronic configuration was 287. So it needed 1. But do you know why this carbonate took 2 electrons?
No, sir.
Don't know why carbonate. See, what I was guessing, this oxygen, Natras says because compound. Natras, you will like to answer this question? See, I'm very happy if you can explain me why.
Sir, it's a negative compound and it can receive 2 electrons.
That I know. Like, But see, what I'm trying to tell Natras is this chlorine has 287 electron, right?
Yeah, so it can receive electron, one electron.
It can receive one electron. But can
Yeah.
you tell me the same way why this carbonate needs two electron?
No idea, sir.
Ishan, you know the answer for this one?
Sir, I guess to balance the third oxygen.
Ishan is saying this carbonate is CO2 plus O. This is balanced, so to balance this one is what you mean?
Yes, sir. Because
Okay,
4
fine.
it will be divided to 2.
See, you're somewhere close. Okay, you're somewhere close, but let me just try to understand this in a better way.
To make it stable.
Obviously, to make it stable, that is like a theory answer, but I want a more logical way of looking at it. Something, see, this chlorine has 287, it means I can understand this, but I cannot understand why will this become balanced. Okay, so try to understand this. It's not that difficult. It will help you in chemistry even this year and further year. Okay, so your chemistry will become a little bit more interesting. Now, carbon has 4 electrons in the outermost shell. I think every one of you understand this, right? Isn't it? This carbon found 3 oxygens roaming around. Okay. This oxygen had 1, 2, 3, 4, 5, 6 electron. This oxygen also had 1, 2, 3, 4, 5, 6 electron. Okay, I'm drawing one of these electron on this other side. And this oxygen also had 1, 2, 3, 4, 5, 6. You can draw electron anywhere you want. That is not a problem. Fine. This carbon has 4 and they have 6, 6 and 6. This oxygen starts sharing 2 electrons with this carbon. Is that fine? Now this oxygen gets 2 more electrons. That makes it 8. And this carbon gets 2 more electrons, which makes it 6. I hope this part is clear to everyone. Now what happens further? This carbon shares 1 electron with this oxygen and shares 1 with this oxygen. This way this carbon gets 2 more. That makes it 8. And this oxygen becomes 7. Is that fine? So there are a total of 1, 2, 3, 4 covalent bond. After this whole thing is over, now this oxygen says, I am done sharing. Now I will take the last electron from whoever gives me. Okay. So suppose sodium gives the electron to this oxygen and this oxygen. So this whole thing here in the between, which has effectively taken 2 electrons from 2 sodium, is called as carbonate. And this is 2 sodium cations giving 2 electrons. So the full molecule is called as sodium carbonate. Is this thing clear to everyone? Does anyone has a doubt about the structure of carbonate? You can ask me now. See, we are actually learning the valency of carbonate in a very wrong way till now. Okay, so I just want to make an attempt to help you understand this better, because it's not such a difficult thing that you cannot understand. Though it is nowhere in your syllabus, but if you can understand, it will only help us in improving our understanding of bonding. Clear? Aswarya, you understood what we are discussing here? Okay, what about the few people typing in more often? Ishan, Daksh, Jayesh, Aishwarya, Natras, Pradipta. There are more people. There are 47 people in the class. Rakshit, okay, Rakshit, Yashish is also okay. These people are typing in. I want new people. Shreya, okay. Thank you, Shreya. I wanted you to type. Viksha, yeah, good. Okay. Manjunath understood. Manjunath, Devraju also understood. BK also understood. Very good. See, this is how you have to reply. Okay. So see, anyway, we have to practice chemical bonding like a bit. So it's always better to. Okay, let me just refresh this page because there's a connection error. Nothing will get deleted. Okay. So moving further, if I take some more example, I'm pretty sure you are interested now in the structure of nitrate, NO3, or nitrite, NO2, 1 minus. This is nitrite. Okay. This nitrogen has 1, 2, 3, 4, 5 electrons in the outer cell. It just found 2 oxygen roaming around, which had 1, 2, 3, 4, 5, 6 electrons. This oxygen also has 1, 2, 3, 4, 5, 6 electrons. Okay. Then this nitrogen asks this oxygen to share 2 electrons. Same thing it does with this oxygen also. Now after sharing 3 electrons, this nitrogen gets total of 5 plus 3, which is 8 electron. This oxygen gets 6 plus 2, which is 8 electrons. And this oxygen gets 6 plus 1, which is 7 electrons. This needs one more, correct? So what it decides that
Take some sodium.
take 1 electron from someone else, right? This is how this NO2 has overall taken just 1 electron, and the valency is NO2 minus. Okay. And that is taken by, if it is taken by potassium, it will become potassium nitrite. If it has taken from sodium, it becomes sodium nitrite. If it has taken from anyone else, it will become that nitrite. Dakshis, are these are important? Not really. Do you have a next question after that? Don't have a, please don't come with a Okay. So, see, please don't tell me, sir, then why are you teaching this? Okay, because what I want to do here is prevent you from rote learning. I can promise you this is nowhere in your syllabus, and you might just never get even a chance to learn this again. So just I'm trying to prevent you from simply by hearting all these valencies. Okay, it's a one-time.
So can you repeat this one once again?
This nitrite.
So.
See, I'm just saying nitrogen has 5 electrons, 1, 2, 3, 4, 5 to start with. This oxygen has 6 electrons, 1, 2, 3, 4, 5, 6. This nitrogen shares 2 electrons with this oxygen. This way, this nitrogen gets another 2. Okay, so this is sharing 2 with this oxygen and 1 with this oxygen. So this nitrogen gets 3 more, which is total of 8. And this oxygen gets 6 plus 2, which is total of 8. Okay, this oxygen gets 6 plus 1, which is total of 7. It needs still one more, so that it will take from some metal cation or some metal and form an anion. So that is why this NO2 has just taken 1 electron. Rest it is sharing inside. Is that fine?
Yes, sir. Yes, sir.
So that is how the nitrite looks like, NO2 minus. Okay, Natras, can you hear it now? Me now? Is it fine? Yeah, okay. So anyway, you understood this part. Now I quickly tell you, what if there is another oxygen roaming around? Okay. What if there is another oxygen around? This has 6 electrons. It says I have 6, I need more, 2 more. It tells this nitrogen that
Get some nitrate.
who is speaking? Someone is trying to speak. If you know, you can tell me. See, what I'm trying to tell here is this nitrogen will form a coordinate bond with this oxygen. This nitrogen doesn't need more than 8, so it is happy. This needs 2 more. So the nitrogen will share this lone pair of electron and form a coordinate bond. Did you understand this? This way, this will form NO3 2 minus, which is a nitrate. Okay, I hope this is clear to everyone. So I think you understood the difference between a nitrite and a nitrate. Okay, this is still -1. This is not -2. Because whether you take a nitrite or you take a nitrate, both just needs 1 electron for this oxygen. Okay. So let's try reconnecting. So the lone pair was hidden before. Oh, no, it was still there. Yeah. See, nitrogen had 1, 2, 3, 4, 5 electron. Earlier, it was not sharing. Now it is sharing. It depends on the mood of nitrogen. Fine. Nitrogen is very moody. It depends on the mood of nitrogen. So, see, I'm just showing you other applications of coordinate bonding, which are there in your syllabus, but we just forget to, we try to ignore them. I hope this way of looking at things will just make your understanding of anions better. Okay. What we have done till now, we have already finished with your syllabus of chemical bonding. So I wanted to utilize the rest of the time to help you practice some examples so that you become really comfortable with bonding and presenting real life example rather than random. Yeah, tell me. I can hear you. Can you please speak up? Okay. See, even if you have doubt, no, you can just text me, sir, I have a doubt, or like just DOU something, and I will ask you to speak up. Fine. I'm constantly watching your chat box. Most of the people are saying yes, okay, and no doubt. Okay, so if someone has a doubt, I'm very keen on observing that one, and I will certainly reply back or give you a chance to speak up if you say something like that. Okay. So I hope you're comfortable with carbonates, nitrates, nitrites. Okay. There are some more, which is important, which is sulfates. Let's try a sulfate. This sulfur has 1, 2, 3, 4, 5, 6 electrons. Okay. It finds 2 oxygen first and combines with it. Shares 1 electron, just 1 electron. All right. The sulfur had 6, so it gets 2 more. That's already 8. Now this sulfur says, let me use this lone pair of electron to form a coordinate bond and help this oxygen. And same, I'll use a coordinate bond and help this oxygen as well. Okay. And these 2 oxygen can take their last electron from someone else. Okay. So this is how our sulfate looks like, SO42 minus. Is that fine?
It's fine.
It's fine, right?
Yes.
Who is that? I can hear some very... Okay. Now, if some other day the sulfate decides that I'm not helping two oxygen, I'm just helping one oxygen. This will be called as sulfite. Is that right? That entirely depends on the mood of the sulfur. Some other day it is in another mood. It says I'm not helping two oxygen, I'm just helping one oxygen. Okay. Okay. Then some other day the sulfur has another mood. It tells this oxygen decides that why to take from someone else. Let's find a hydrogen and share electron with this hydrogen. Okay. This is when it becomes hydrogen sulfate. And the valency is HSO4, just 1 minus. I hope this is clear. Okay. Some other day, this sulfite decides that I will not share electron with, like take from anyone else. I'll just share it with another hydrogen. So this oxygen is already happy. Now you need just one. This is called as hydrogen. Yeah, once upon a day. So this is hydrogen sulfite. Okay, all these are moody people. They behave in different ways. So if they are doing this, or they can do this, or they can do that. Okay, so I hope you are understanding the structures of these molecules, these anions, which are really important in your syllabus. Okay, these anions are really important in your syllabus. You talk about them every single chapter of chemistry. I think one day we can spare this little half an hour to know their structure. Okay, that much charity we can do on these anions, right? Good. I've heard one more like very often in my chemistry, which is peroxide. This is different from a normal oxide.
NGO.
A normal oxide is when one oxygen has 2 electrons and like 6 electrons, and it takes 2 electrons to get the valency satisfied. This is the normal oxide. Now the peroxide is a bit different. So if this oxygen suppose takes, like one oxygen takes 2 electrons from 2 sodium or a magnesium, this is called as a magnesium oxide. Peroxides are a bit different. Peroxide is O2 2 minus. This is O2 minus and that is O2 2 minus. So some other day, as we know, once upon a day, this oxygen sharing 1 electron with another oxygen. Okay, one oxygen, like 2 of them decides to share one electron. Okay, and now they just need one electron more. So earlier just 1 needed 2 electron, now 2 needs 2 electron. This is peroxide. Suppose magnesium gives these 2 electron to these oxygen from 2 sides. This will become magnesium peroxide. I hope this is clear to you. Okay. There's plenty of other anions, cations, zincate, plumbate, aluminate. I can discuss about all of them a whole day. Okay. But if required, we will do that in later chapters whenever it is. But these are some of the important ones, common ones, which you see all the time. At least you should be knowing a bit about them. Yeah, not today, Daksh. Some other day. During the chapters, if we come across those anion, and if I feel that I should be discussing the structure of that anion, I will try to do that. We'll make this as a point, like whenever we are discussing chemical reactions, because in the coming chapters, after this chapter, you will be having plenty of chemical reaction. And whenever we are discussing a chemical reaction, like ammonia combining with oxygen to form N2 plus 2H2O. You have copper combining with nitric acid to form copper nitrate with NO2 and H2O. We have plenty of such reactions coming in this year, and they are approximately, by my calculation, about 40 reactions which you should be thorough with at the end of this year. Not just knowing the balance reaction, but you should know the nature, the color of the gas released. You should be knowing that this ammonia is burning with a green color flame. You must be knowing this copper nitrate is a reddish brown precipitate, green color precipitate, and this nitrogen dioxide is a reddish brown color gas, because the question will be asked like this: name the color of the gas released when copper reacts with nitric acid. Okay, if you have some experience of seeing the paper, that will be like this. Now, yeah, you might get confused with the color, and that is the thing we have to practice. So that's the whole idea why I'm discussing in detail about the structure, because when I'll be discussing about every single reaction with you in extreme detail, okay, and we will be learning stories around each of these reactions so that you can easily remember it. Okay, so I can assure you that I am not going to make you mug up any reaction as soon as we start. That won't be a problem, Sweta. Sir, how we know that valency taken for an element with variable valency when it is not mentioned? See, generally that is not a big concern, though just because you mentioned it, there are some special instances like you don't have, they won't be saying find the formula of iron chloride and they won't give you the valency. That is a wrong question itself. But one example is in acid, bases and salts, they say write a chemical reaction for the preparation of iron 2 chloride. Iron 2 chloride means FeCl2. So when they say write the chemical reaction, this is the question which is asked in board. Name the chemical write the chemical reaction for the preparation of iron chloride. You must remember in those reactions that when iron directly reacts with acid, it forms like the valency of iron is 2 plus, it forms iron 2 chloride. And when iron burns in the presence of chlorine, it forms iron 3 chloride. So I'm just giving you an idea about few things which will be coming further. Okay, it won't be tough. See, you can ask me any reaction from any page of your chapter. I'll be looking into the camera and I can tell you the reaction in its balanced form. It doesn't take too much effort, I can promise you. Just that we need to relate it with some interesting stories so that we can remember it. Okay. You ask me any reaction later when we are doing reaction from any page of your textbook, I'll be able to tell you, I can promise you. Okay, and I'll make sure that you can also do that. So I think that is enough for today.